All right, so on these functions, we're told something like this is a quadratic function, y equals f of x, but we don't actually care. What we care about is that there's a coordinate that we were given that's meeting in this function f of x notation, and we're told there's a second function g of x that's defined as taking f of x and subtracting 5 from it. And we just need to know what would the new coordinate be if that was to occur. Well, f of x minus 5 is using function notation to represent that all the y's from f of x, because f of x is y, need to have 5 subtracted from them, and that will produce this new function g of x. We just have to do it one time for this one coordinate and understand that the 6 is the x value. It doesn't change, but all the definition of g says that we're supposed to have all the y's subtract 5. So we just take 3 and subtract 5 from it to get the new y output for g. And so the coordinate that we put in here as our answer is 6, in parentheses, comma, -2. So all we have to do is take our prior knowledge of function transforms and apply it here to a single coordinate situation. On the second example, it's a little bit more exciting because inside the parentheses, there is the change. And just like before, they were told that there's this quadratic function f, but what the goal is we have a coordinate, and we want to know where does that coordinate go if g of x is defined to be f of x plus 3. Well, our function transform understanding knows that anything added in with the x causes the function to go left or right, but the key is opposite of the sign. So what I'm afraid of is that people look at this x plus 5 and they go, oh, well, you just do 3 plus 5, comma 5. So that's what it feels like you're supposed to do because it has x plus 5 in there. But we have to remember that functions translate inside with the x, left to right, opposite of the sign. So it's not plus 5. It's got to be minus 5. I know our plus 5 there, we're like, oh, yeah, just add 5. No, you have to think about this means this new function g actually shifts to the left 5. So we need a minus over here. So our new coordinate is going to be 3 minus 5, comma 5 for a new coordinate of -2 in parentheses, comma 5. It's a little bit tricky because it says plus 5, but remember it's opposite of the sign. You're actually minusing 5. On this final example, we are going to affect both the x and the y. Again, we're told there's this f of x that's a quadratic. We don't really care. What we care about is there's a coordinate, and that g is defined in terms of f. F produced the coordinate, so we get to play with that coordinate through this lens of the function f needs to shift to the left 2, so I need this coordinate to go left 2, and down 2. But again, that left 2 comes from the opposite of the sign, so it's plus 2 there. You don't take the x and add 2. Well, the way we run it through is actually needs to be take the x value of 4 and subtract 2 because of this 2. And then we need to take the 6, so comma 6, and subtract 2 because that moves the y values down 2. So we take that same understanding we've been playing with function shifts, understand that the left 2 means you subtract 2, and that this minus 2 means you go down 2, and the down 2 goes to the y, the left 2 goes to the x's, for a final coordinate of 2, comma, 6 minus 2 is 4. And that's how you do coordinate one by one with function transformation in function notation.